Good day, ladies and gentlemen. My name is KAMVA MVAKADE. I'm teaching physical sciences. I will be doing vertical projectile motions. Under vertical projectile motion, I will be doing the sketching of graphs. Let me take you through the outcomes of these presentations. Now, after this presentation, one must be able to sketch a velocity time graph and a displacement time graph for a ball that is projected vertically upward, and must be able to sketch a velocity time graph and a displacement time graph for a ball that is projected vertically upward and returns to the initial position. Sketch a velocity time graph and a displacement time graph for a ball that is projected vertically upward and passes the initial point and hit the surface below. Okay. Under vertical projectile motion, we use the equations of motions to calculate the unknowns during the motion of an object. The following equations will be used in the examples of this lesson. Now, these are the equations. These four equations are the equations of motions. In each equations there are four unknowns. 1, 2, 3, 4 in each of them. 1, 2, 3, 4. So what is going to happen is we are going to be given 3 in each equation. For example, we can be given the final velocity, initial velocity, and acceleration, and we will have to find the unknown, which is going to be the time, or we can be given the time, acceleration, and vi, and we solve for one unknown. So in most problems, that is how we are going to find the unknowns. Now, coming to the velocity time graph. The velocity time graph is a straight line graph. We know in mathematics a straight line graph is represented by this hypothetical equation: y is equals to mx plus c. Now, the velocity time graph, where velocity is a function of time, as a function of time, and we know that from the mathematical equation that this c represents the y-intercept. Even here, our initial velocity will also represent the y-intercept. Changing x is the variable, and then our variable will be time. So we want to see how velocity changes with time, because in mathematics we want to see how y changes as a function of what? Of x. So m is the gradient, which is constant, and also the gravitational acceleration is constant. Yes, we know that it is 9.8 meters per second squared downward. The displacement time graph is a parabolic graph. This is a hypothetical equation for a parabola, and they use this one in mathematics. But if we take our displacement as a function of time equation, and then we rearrange these two parts, it looks more like a parabola. So as we plot the displacement against time, we are going to get a parabolic graph. Now let me start with the first one. I said I will be doing sketching a graph for a ball that is projected vertically downward. Let's say we've got a ball from the top of a cliff, or from the top of a building, or they can say from the top of a bridge, and a bridge that is 25 meters high. For example, it is projected at a velocity v there, v, let us see, which is velocity 10 meters per second. Now since we are dealing with vectors, velocity, acceleration and displacement, those three are vectors, and the time is a scalar quantity, so we need to indicate the direction when working with these equations. So in most of my of the problems that I will be working on, I will be taking upward as what? Everything that goes up as positive, and everything that goes down, I will be taking it as negative. So let us say this ball is projected vertically downward, it comes here and hits the ground somewhere there, and hits the ground somewhere there. So if we want to plot the velocity time graph, in this case we're going to say we've got 2 points. Now the 2 points that we have here is the initial point here. I will say, let us say this is A, this will be A, and the final point here, this is going to be B. So if we want to plot the velocity time graph for this type of motion, we need to get the time initially and the velocity at that time. We also have to get what? The time here, time at B, and the velocity at that time. So we can represent this as coordinates and say we want to get the time here, let us say is TF at T final, and we also have to get what? The velocity final. And also the at A, what is it that we must get? We must get the time initially, and we must also get the, which is T, let's just say is TI, and we must also get the velocity there, the VI. So we have the coordinates. So if we've got this information, the time and the velocity there, the time it hits the ground and the velocity at which it hits the ground, now this will make things easier for us to plot the graph. Now let us come again to the second one. This was the first one. Now let us come again to the second one, where a ball is projected vertically upward and returns to the initial position. Now in this case, let us say we are on top of a roof. Now a ball is projected vertically upward and returns to the initial position from where it was thrown. So in this case, I want us to say we've got 3 points. We've got the initial one here, which we say this is going to be A, and we've got what? The second one there, the second one here, which is the maximum, at the maximum point. This one is going to be our B, and the final one, when it returns to the thrower's hand, this is going to be C. So for us to plot the velocity time graph, we must get the time here, the time at A, and the velocity at A, and we must also get what? The time at B and the velocity at B. We must also get what? We must also get the time here at C and the velocity at C. So if we can just get this information, time at A, velocity at A, the time at B and the velocity at that time, and the time at C and the velocity at C, we will be able to plot what? To plot the graphs. So you will see as we go through the examples. For now, I just want you to understand how we go on about sketching the graphs. Now the third one, let us say the example, the third one, we say we've got what? We've got a ball that is projected vertically upward, and it passes the initial point and hits the surface below, somewhere there. So in this case, I want you to think of it like this, to say now I have 4 points. Now this one is going to be A, this one is going to be B, and here we're going to have what? C, and now there is going to be what? Is going to be D. So for us to plot like we did with this one here, we need to get what? We need to get the time at A and the velocity at A. We need to also get what? The time at B and the velocity at B. We also have to get the time at C and the velocity at C at this point. Now we also have to get the time at C and the velocity at C. Okay, that was what? That was for the velocity time graph. The same will apply for the displacement time graph. This side will be there. Let me write saying for velocity time, and then this side I want to do for displacement time graph. The same will apply for number 1. We've got a ball that is projected vertically down, vertically down. Okay, vertically down. So this one is going to be A, this one is going to be B. So for us to now, it is what? It is now displacement against time. Here it was velocity against time. So now at this point we need to get what? The time at A and then displacement at what? At A. We also have to get the time at B and the displacement at B. With these 2 points, we are going to be able to plot them on the Cartesian plane. Now the second one is when a ball is projected vertically upward and returns to the initial position. Now I said if we've got this type of motion, we can think of it as if we've got 3 points. Now this one is going to be A, B and C. What you need to get the time at A and the change in Y at A. You need to get the time at B and the displacement at what? The displacement at B. Now I want you to we need to have what? The time at C and the displacement at C. With these coordinates, now we can be able to plot them. If we have this information, we can be able to plot them on the Cartesian plane. Number 3, going to do the same. It is projected vertically up, returns, passes the initial position and hits the surface below. Now how many points do we have in this case? 4. 1, and the highest point when it returns to the position and when it hits the surface below. This is going to be A, this is going to be B, this is going to be C, this is going to be D. You still do the same. What are we going to need here? We are going to need the time at A and the displacement at A, the time at B and the displacement at B, the time at C and the velocity at C, the time at D and the velocity at D. Having this information, time at A, displacement, time here and the displacement there, time here and displacement here, time here, and no, changing y at C, changing y, sorry for that, changing y at D, displacement, the time here, and the displacement. Having all that information, we can be able to plot the graphs on the Cartesian plane. Now let us do the first example. Now we've got we've got example 1. A ball is projected vertically downward at a velocity of 12 meters from a 60-meter high building as shown in the diagram below. Okay, calculate the time it takes to reach the ground. Okay, I said we need to indicate the direction. I will be taking upward as what? As positive, and then I will be taking the direction of downward as negative. So this velocity here, this ball is projected vertically down. So meaning if I have to collect my data here, my initial velocity VI is going to be equal to negative 12 meters per second. Okay, now with this height displacement, for displacement, I want us to take the initial position of the ball, of the object, where it is projected. This point here, this is going to be our reference point, the initial position of the ball, and this is going to be what? 0 meters. Now since this ball here, it's our reference, is 0, and going down from a number line, if you've got 0 here, we know that upward here, this side, when you go up, these numbers are going to be positive, and all the numbers below 0 are going to be negative. You are just going to have what? Negative values, maybe negative 5, negative 10, negative 15, and then going down like that. But here these numbers are just going to be positive. So if we take the initial position of the ball as 0, that part, initial position, as our reference point, as our 0 reference, now this is going to be 0 meters, but this ball goes down. It goes down. Let us say this is our what we call our Cartesian plane. All the values under 0 are going to be negative, and then all the values up there are going to be positive. So the displacement that is covered by this ball is this one. So this is just the height of the building, but if we want to get the displacement of the ball, it comes from there to here, which happens to be covering what? The negative displacement. So our change in y in this case is going to be negative 60 meters, because displacement it's a vector. And then the other one is the gravitational acceleration, which is always there, which is always negative 9.8 meters per second squared. Squared. And now what is it that we need here? They said we must calculate the time it takes to reach the ground. Now we must do what? We must get the changing time, which is the unknown. Okay, what is it also that we do not know? We do not know the velocity at which it hits the ground from there to here, which is our VF. We also do not know this velocity, and we also do not know the time it takes to get there. So that is what we need to get here. And then once we got the time there and the velocity there, we got the time, obviously initially the time is 0. Now this is our A, this one is our B. The time is 0 here, and the velocity is negative 12 going down. Now we need to find the time here and the velocity here. Since we've got that information, we'll be able to sketch the velocity time graph, and also we will be able to sketch the displacement time graph. Let us calculate the time it takes to reach the ground. Now for us to get the the time, we must be using the equations of motions. Now from the information that we have here, we must choose the right formula. Now in our case, in this case, let us see what do we have. We've got the initial velocity there, displacement and gravitational acceleration. What we want is time. So the formula that is right to use in this case is going to be this one, because what do we have? We've got displacement, we've got VI, we've got acceleration. What are we looking for? We are looking for time. Now that will be what? That will be changing y is equals to VI changing time plus half g changing time squared. Now our displacement is negative 60, and then VI is negative 10 changing time plus half. The gravitational acceleration always goes downward. It always take it is always down, the gravitational acceleration, which is going to be negative because we took the sign of going down as negative 9,8, and changing time squared. And now we need to solve for time, and then what we're going to do, let us say negative 60 is equals to minus 10 changing time. Here this is going to be negative 4,9 changing time squared. Now I'm going to transpose this 2 to the other side, so that and then arrange them in such a way that they are in standard form. So this is going to be 4,9 changing time squared plus 10 changing time is minus 60 is equal to 0. So now we need to solve for time. Now in mathematics, we know we've got the quadratic equation that can help us to find t. So t changing time is going to be equals to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Those students who are doing what you call pure mathematics, they are familiar with this formula, which is the quadratic equation. So now I have to substitute. Now what are we going to have? Negative, this one is b, negative into 10 plus or minus the square root of what is b is 10 squared, minus 4 into a is this one, and that will be 4,9 into negative 60. Negative 60 divide all this by 2 into what? 4,9. So let me find the time. Now I have to do these two equations separate for positive and negative. Okay, now what do I have now? I'm going to have negative 10 into plus the square root of 10 squared minus 4 into 4,9 into negative 60. Yes, and then 2 pen bracket 4,9. The time is 2,62. Changing time, let me say it's 1, or changing time 2. Now I have to do for what? For negative there. When we've got, I use positive first, I have to use negative now. And negative 4,665. We know this one here, it is invalid. This one here is invalid because time is a scalar, it's a scalar quantity, so it is always positive. So our correct answer here is going to be what? 2,62. So the time it took this ball to reach the ground here is 2,62. Okay, so we can have what? The coordinates there. Let us say our time here is what? Is 0, and then what is the velocity? Minus 12. And then here at B, at this point at B, the time is 2,62, and the velocity, no, we don't have what? We don't have the velocity yet. We do not have the velocity yet. So I will come to calculate the velocity there. Now let us calculate the velocity. Now for the velocity, we can say what do we have? We know now that the time to get to reach this point here is 2,62 seconds. 2,62 seconds. So we can use the first formula, which seems to be the easiest one, this one, because we've got VI, we've got acceleration, and we've got what? The changing time. So where I use G in my equations, that G represents the acceleration, because G is the gravitational acceleration. Now we'll be using VF is equals to VI plus G, changing time. Now initial velocity is negative 12 plus negative 9,8. How many seconds did it take to reach there? 2,62. So what is the velocity? The velocity is going to be negative 12 plus 9,8, 2,62. Now it is negative 37,68 meters per second. So the velocity here is what? It's negative 37,68. So now what do we have? We've got the time, and we also have what? We also have the we also have the time and the velocity. There we've got the time and the velocity. So now you can go and sketch the velocity time graph on the Cartesian plane. Good. Now and then you write velocity versus time. Velocity versus time. But here, if you draw this, you must use what? You must use a ruler for what? For accurate, to have what? Accurate values you can say here, maybe use the what you call centimeter and say here, because we must have what you call equal spaces in between, and even this side we must also have what equal spaces in between. Now you can say 1 2 3 4 5 6 7 8. Okay, like this 0, and this side you can also have, which is okay. Let's say we got 5 10 15 5 10 15 20 25 25 30 35 40, and this side is what negative numbers. Okay, now we have to plot what, and then this side it's 1 2 3 4, and you write time in seconds, and then on the other side you just write this is velocity in meters per second. Good. Now at A, which happened to be our initial point, we had 0 and negative 12. For velocity time, this side is going to be time, this side is going to be velocity. At B, we had 2,62, and the velocity there, let's check, negative 37,68. Happen to be negative 37,68. Good. 2 points. Like we said, you know that the velocity time graph is a straight line, so we just have to plot 2 points and draw a straight line. Now at time 0, the velocity is 12. This is time 0. 12 is between 10 and 15. Let us say 12, it must be somewhere here. This is our point. Now at 2,62, this one is going to be 2,5. 2,6 is somewhere here, and then we go down to negative 37,68. 37,68 somewhere here, and this is going to be our our point. And then because this is a velocity time graph, is a straight line, we just join the 2 points. Okay, now in our case, our graph has a negative gradient, simply because we took upward to be positive and downward to be negative. If you remember very well, I said this is represented, a straight line in mathematics equals to y equals to mx plus c, and the velocity time graph is vf is equals to g change in time plus vi, and then I said vi is the y-intercept, which happens to be there 12 initial velocity. So m represents the gradient in mathematics, and also our gradient is going to be represented by the gravitational acceleration, which happens to be negative 9,8 meters per second squared. Hence we've got what? A negative gradient. Coming to the displacement time graph. Now with displacement, I said the initial position of the ball, I will be taking it throughout this lesson as 0 reference, as the 0 meter. So here for the displacement time graph, here at A, the let us say for displacement at A, the time is 0 because initial. And then what is the displacement now? The displacement is 0. Displacement is 0. At B here, what is the time at B? The time is 2,62. What is the displacement? The displacement is -60. Because we've got 2 points, initial one and the final one. So we've got all the information that is needed for us to plot the velocity time, the displacement time graph. And then let me use this ruler. How many am I going to need? Okay. Okay, let's see. This is going to be let us see, it's 10, 20, 30, 60. Okay, this is going to be our, this is how you do it. Good. And say equal spaces in between. Yes, and then write time in seconds, and this is what, or let me first say 10, 20, 10, 20, 30, 40, 50, 60. Negative, 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 and it becomes displacement in meters. Good. This is 1, 2, 3, 4. Now for displacement at A, we had 0:0, and B we have 2,62 seconds is to -60. So 0:0, it is the origin. After 2, this is 2,5, 2,62, it's somewhere there in between, and the displacement is what is 60. So our graph is going to curve like this. It's going to curve like that, and there you write displacement versus time. Displacement versus time. So you've got those, and now we are able to sketch we are able to sketch what the velocity time graph for an object that is projected vertically down, and the displacement versus time for an object that is projected vertically down. Now let us get to our next example. Okay, before you go there, let me explain why our graph curves like this one. Like I said, in mathematics, this is the hypothetical equation of a parabola. And then now, what you call, here we've got displacement change in y, half g change in t squared, plus vi change in time. Remember, I said we take what? We took upward as positive and downward as negative. So and then our gravitational acceleration, this one is going to be negative 9.8 meters per second squared. So this g is going to be negative, so this part is going to be negative. If it happens that we substitute g here, we're going to have negative 4.9 changing t squared. And we know that once this a is what is negative, we're going to have a parabola. When this is a, we're going to have a parabola that is what? That is a third phase, But if it happened that you choose to take downward as positive, this means you will have to substitute that as positive, and you're going to have a what? A smiling face, and our our parabola will be curving like this. It should be a smile, it shouldn't be sad. But now since we took downward as negative and we get this negative value here, so it has to be what? A sad face. Okay, let's go to the next example. The next one, where a ball is thrown vertically upward and returns to what? It returns to the thrower's hand. A boy throws a tennis ball vertically upward with the initial velocity of 12 meters per second and returns to the thrower's hand. Like I said, we choose to take upward to be positive and downward to be negative. Okay, now we are asked to calculate the maximum height reached by the ball. So we need to get this height here, So what do we have? Now this ball is projected upward at a velocity of 12 meters per second. So when it goes up, when it's busy going up, now the velocity of this ball decreases with time, because the gravitational acceleration, it's in opposite direction, is downward. So when this ball reaches the maximum height there, its velocity is equal to 0, and it starts to accelerate downward. It accelerates downwards. And now here at this point here, the velocity of the ball is equal to the velocity initially, but the velocity is in the opposite direction. So here v, at this point, v is going to be equal to negative 12 meters per second. The velocity at which it is projected upward is equal to the velocity at which it returns to the thrower's hand, but it is in the opposite direction because it is now coming down. Okay, so we are asked to calculate the maximum height. We know that the maximum height, the velocity is equal to 0. And then now let us collect data for this question. What do we have? We've got v initial, which is 12 meters per second. What do we know? We also have vf, which is equal to 0 meters per second. What do we know? Also, we also know the gravitational acceleration, which happens to be negative 9.8 meters per second squared. But we do not know what? We do not know what the changing y, the displacement. We want this changing y there. We are looking for this changing y. So now we come to the equations of motions, and we check the right formula, the formula that we can use. This one is going to be the right one, because we have what? We've got vf, we've got vi, we've got the acceleration. We are looking for what? We are looking for change in y. So we come to calculate for it. Let's say vf squared is equals to vi squared plus 2g change in y. Now VF squared, this is 0 squared, and then this one is it's positive 12 because it is going upward, and we took upward as what is positive. Plus squared plus 2 into the gravitational acceleration goes down, negative 9,8. We're looking for what? Changing y. Are we together, good people? So this is going to be 0 is equals to what is 12 squared? 12 squared 144 minus 19,6, changing y. We transpose this one, 19,6 changing y is equal to 144. Divide both sides, 19,6, this cancels that, changing y is equals to 144 divided by 19,6. the answer is 7,34 meters upward. Okay, now the time it takes to reach the maximum height. We want to get the time there. We now know what is the displacement of the ball at that point. So the time, let's say this is point number 1, we come to point number 2. For point number 2, we say okay, VF, since we know this one, the first formula is going to be okay because we've got the final velocity, the initial acceleration, and the time, and we're looking for what? For the time. So VF is equals to VI plus G, changing time. So VF is equals to 0. VI is what? VI is 12, positive 12 plus negative 9,8 into changing time. We transpose this one, going to be positive 9,8, changing time is equal to 12. Divide both sides by 9,8, divided by 9,8. This cancels this. The changing time is going to be equal to 12 divided by 9,8, 1,22 seconds. Okay, good people. Now let me explain this one again. So it takes 1,22 seconds for a ball to move from the thrower's hand to the final, what to call, to the maximum height. The time it takes to reach the maximum height. So the time it takes to move from the hand to the maximum height is equal to the time it takes to move from the maximum height to return to the thrower's hand. So if we want to get the total time here, the total time it takes, we are going to say 1,22 multiplied by 2, because we have to add 1,22 and another 1,22. Like I said, we have to break this into what? Into points. Now this is going to be A, point A, that one is point B, this one is point C. Okay, it's point C. Now let us go and sketch the velocity time graph for the entire motion of the ball. Okay, now we have how many points? 3 points. 3 points. We've got A. At A, what is the time? The time is 0 initially. The time is 0, and the velocity is positive 12 because it is projected vertically upward. At B, which is the maximum height, at this point, the maximum height, the velocity is 0. But what is the time? The time it took 1,22 seconds to reach the maximum height. To reach the maximum height, it took 1,22 seconds from here to there. So the time here is 1,22. So the time is 1,22 and the velocity there is 0. At C, which happens to be this point, the time it takes to go up is equal to the time it takes to move from the maximum height until there. So at C, the time will be 1,22 multiplied by 2, which is 2,44. 2,44 is to -12, because we know here, like I said, the velocity at which it left the hand is equal to the velocity at which it returns to the thrower's hand, but it is in the opposite direction. It is negative. So let us plot this graph. Okay. Okay, and then we just draw a straight line here. Draw a straight line. Even this side we have to draw a straight line, and then is going to be time in seconds. 1, 2, 3. So it's 1, 2, 3, and then what do I have? 3, 6, 9, 12, 15. 3, 6, 9, 12, 15. Good. And then we say velocity meter per second. Very good. And then we got those 3 points at 0 times 0. What is the velocity? The velocity is 12. Our first point. At 1,22, 1,22 is somewhere here. What is the velocity? The velocity is 0. At 2,44, the velocity is -12. These are negative. 2,44 is somewhere there, and then the velocity is what? It's -12. The velocity time graph is a straight line. We just have to join all those 3 points. Now you managed to draw the velocity time graph. Now let's come to the displacement time graph. You see here velocity versus time. Let us come to the displacement versus time. Good. You must remember, I said the initial position. I messed that one. Let me draw another one here, and then this was the motion of the ball. I said this part, which is the initial position of the ball, we take that as the zero reference, which is 0 meters. And then with displacement, for us to get the displacement, I said we must represent displacement on a number line. Now we know that this one is going to be what? This one is going to be the positive side on the number line, and this one is going to be what? We are going to have the negative numbers. This is going to be our 0. So which happened that our ball moved upward to this part, and that part was how much? It was 7,7. 7,34 meters upward. So it reached 7,34. Okay, and it took what time to go there? It took 1,22 seconds to get there, and then it returned to the initial position. From here it moved there back to 0. Okay, so we've got A, B and C. So for displacement, which points do we have? We've got A at time 0. What is the displacement? At this time the displacement is 0. And at B, what is the time when it reaches there? It's 1,22. 1,22. What is the displacement? The displacement at that time is 7,34. At C, what is the time? Is 2,44, because we multiply the time by 2. From here to there it takes 1,22. From here to there 1,22. And then what is the displacement? It returned to the initial position, so the displacement is 0. Now we've got all the information that is needed for us to plot the displacement time graph. And we say 1, 2, 3. 1, 2, 3. Time in seconds. The time in seconds, and this one is 2, 4, 6, 8, and then 2, 4, negative. This side we write displacement in meters. This side is time in seconds. So what did you get? At A it was 0:0. B 1,22 is to 7,34. At C 2,44 is to 0. Now come at 0, 0, first point. At 1,22, which happens to be somewhere there, 7,34. 7, this is going to be 7,34. It's somewhere there. Our point is there, and then after 2,44, it's somewhere there. It returned to the initial position, which happens to be 0. So our graph will be a parabola with the said face. Just to curve. Okay, like that. Sorry for this, but you will use a pencil to make a right curve. Okay, I hope we're still good. Now let us do the last one, the last example. Now a ball that is projected upward and passes the initial position and hits the surface below, Now a girl stands on a bridge 11,25 meter above the ground. She throws a ball vertically upward at a velocity of 10 meters per second as shown in the diagram below. This is what happens. And now they say we must calculate the maximum height, the time it takes to reach the maximum height, and the time it takes to reach the ground. Okay, now here at the maximum height, we know that the velocity here is equal to 0. So we need to find this height. Okay, we need to find that height. and we know that the gravitational acceleration g is equals to negative 9.8 meters per second squared. Okay, so the right formula will be the first one, this one, because you got vf, vi, acceleration and time. So let us get to the first point. Vf is equals to vi plus g, change in time, 0. It is projected upward because we take upward to be positive. Now that 10 meters per second, 10 meters is going to be positive. 10 plus into negative 9.8, change in time, transpose this one, 9.8, change in time is equal to 10, and then we divide both sides by 9.8, 9.8. We have to get the change in time, and then 10 divided by 9.8, 1.02 seconds. The time it took to reach what? The maximum height, 1.02. So since it took 1.02 to get there, it takes the same time, 1.02, to move here to here. But the time it takes to move from here to here, it will be what? 1.02 multiplied by 2. So the time here at this point, the time at this point is 2.04 seconds, the time here. Okay, and we know that the velocity at which it leaves at this point is equal to this velocity at this point, but it is in the opposite direction. So the velocity at this point is going to equal to negative 10 meters per second. The velocity at this point here. Good. Now the time it takes to reach the maximum height. The time it takes to reach the maximum height. Oh, what a mistake. So it happens that we calculated this one first, because this is what we got. This one is for this one. We got that time to reach there. So we need to find what now? The maximum height. So we can use change in y, which happens to be this one. Change in y is equals to vi change in time plus half g change in t squared. The initial velocity is 10. It takes 1.02 to get there. That's half into negative 9.8, 1.02 squared, which happens to be 10 into 1.02 plus half negative 9.8, 1.02 squared, 5.01 meters upward. We've got what now? We've got change in y there to get there. The displacement here, you know the displacement there. We've got the time it takes to reach the ground. So we want to know the time here. What is the time? What is the time here? What is the time? Okay, so for that time, good people, since I said at this point here, this is what happened. This ball went there and came down there. Okay, and then I said we can represent this when we come to displacement. We can use the number line. Now we said this is the initial position of the ball. This is the 0 meter. So this ball left from this position and went up to 5,1 meters, and then now it returned to what? It returned to 0, and then as it returns to 0, it now takes, because this is what? Positive side, and this one is the negative side. Now it takes the negative displacement, this part, the negative displacement, which happens to be 11,25, which happens to be 11,25. So the displacement of this ball as it reaches the ground there is going to be equal to negative 11,25 meters. The displacement of the ball from here to here, because it went there 5,1 and returned to 0. Now it takes the negative displacement, which is negative 11,25. Now let's collect the data for us to calculate that time. Now we've got VI, which is equals to positive 10, because it moved there from 10 upward, then it went there. So, and then the change in Y, the displacement is negative 11,25, negative 11,25 meters. And we've got what? G, negative 9,8 meters per second squared. What do we need now? We need to get the time. The change in time is unknown, so we have to get the time there. So the right formula to use in this case is going to be that one, because we've got VI, acceleration, and displacement. Okay, now we're going to say change in Y is equals to VI change in time plus half G change in T squared. This is negative 11,25 is equals to VI is how much? Positive 10. We're looking for time, plus half into negative 9,8 change in time squared. And then now negative 11,25 is equals to 10 change in time minus 4,9 change in time squared. We transpose the two and put this in standard form. This is going to be 4,9 change in time squared minus 10 change in time minus 11,25 is equal to 0. Okay, now we are looking for what? For time. Okay, so we need to do what? We need to get the time, so we are going to use the quadratic equation. So I will write that quadratic equation there. So change in time is going to pass to negative b plus or minus the square root of b squared minus 4ac divided by what? Divided by 2a, which is going to be change in time is equals to negative into b is minus 10 plus or minus the square root of minus 10 squared minus 4 into 4,9 into negative 11,25. All this divide by 2 into 4,9. Change in T1 is equals to, and then let's do it, negative into negative 10 plus the square root of negative 10 squared minus 4 into 4,9 minus 11,25. Okay, 2 into 4,9 is equals to 2,84, 2,85 seconds. Or changing to 2, we change here because we use positive, we have to use negative now. Negative, this one is what? Is invalid. Invalid. Okay, so now we've got the time. The time it takes to reach the ground there. We've got that time. Okay, the time here is from there to there. The time here is 2,85. 2,85 to get there. Okay, so what do we need now? We also do not know what the velocity at which it hits the ground. Okay, with the velocity we can quickly do it here. We can quickly do it here because we are just going to use VF because we have everything now. We can use VF is equals to VI plus G, changing time, this simple one, which is going to be equals to 10 plus negative 9,8 multiplied by what? 2,85 there, like that. And then what are we going to get? 10 plus negative 9,8, 2,85. Yes, so it hits the ground at negative 17,93 meters per second. So we know here that the velocity is 17,93 and the time is 2,85. Okay, good. So now in this case we've got 4 points. We've got A here, A, B, C, here is C, and this one is D. This one is D. So I will just write them on the next page. Now at A, what is the velocity at A? The time is 0 and the velocity is positive 10. Okay, so at B, which is the maximum height, the time is 1,02. the time it takes to reach the maximum height. There at B, the time is 1,02 and the velocity is 0. At C, what is the time at C? The time at C is 2,04 and the velocity is minus 10. Yes, because the velocity is positive 10, this side is going to be negative 10, but in the opposite direction. And now what is the time at D? The time at D is 2,85 at the velocity of negative 17,93. So we have all that we need. So let us just plot the graph. So this is going to let me see. Okay, let's use what to call 2, 4, 6, 10, 12, this is 510. This is 510. No, 510. It's not going to work for us. Okay, let's use 5, 10, 15, 10, 5, 10, 15, 20, 25. Okay. 0 there. Okay. We got 5, 10, 15, 20, 25, negative, 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 5, 10, 15, positive ones, and then okay, and then 1, 2, 3, and the time is in seconds. And here what we have, this is velocity in meters per second. Velocity meters per second, and there you write velocity versus time. Good. Now it's 0 and 10. 0 here and 10. There you go. At 1,02 and 0. 1,02 is somewhere there, and the velocity is 0. At 2,04, 2,04 is somewhere here. It goes with what? Minus 10. Goes with minus 10. Somewhere here. And then at 2,85, 2,8 next to 3 there, what do we have? We've got 17, which happens to be somewhere here. 17,93. It will be somewhere here. And then we've got what? We've got a point there. Okay, we plotted all those points. Now you can do what? You can draw your straight line. That is a velocity time graph for a ball that is projected vertically upward, and it passes the initial point and hits the surface below. Now let us come to the displacement time graph. Displacement time graph. We've got 4 points. Let me write them here. 4 points. We've got A, B, C, D. We're going to have the same times as those ones. The times will be the same, 2,85, and then 2,04, 1,02, 0. So all that we need to do is to get what is the displacement at these times here. With these times. Okay, good. If we get back here, initially I said we take the initial position as what? As 0. So initially there in the number line we're going to have 0 is to 0. After 1,02 seconds, what happened? It was there, and the displacement is what? It's 5,1 meters, the maximum height, which happened to be this one, 5,1 there. Okay, after 2,04 seconds, what happened at C? At C, moved from here to there and returned to the initial position. And at the initial position, that is the 0 reference, it went back to 0. So we have what? We've got 0. So after 2,85 seconds, what happened? After it returned to 0, it took the negative displacement of 11,25 meters. Hence, I had negative 11,25 meters. Negative 11,25. We have all the information that we need. Okay, we need to plot this on a Cartesian plane. Okay. I'm going to Okay, let me just do this. Our 0 is there, and then sorry for that, and then 1 2 3 4 time in seconds, displacement in meters. Now 2 4 6 8 10 2 4 6 8 10 12 negative 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 negative. Okay, now for a 0 is to 0, we have it there. 0 is to 0 at a, 0 is to 0 after 1. Okay, we need to write 1 2 3 4. Okay, those terms, sorry for that. At 0 is to 0 at a, now we come to b, 1 comma 0 2 and 5 comma 1. At 1 comma 0 to 1 comma 0 2, it's somewhere here, and then 5, it's in between there. 5 comma 1 will just be above 1, just above 1. We're going to have it there. At 2 comma 0 4, the displacement is 0. The displacement is 0. You put it there. And then at 2 comma 85, the displacement is negative 11 comma 25. 2 comma 8, it is next to 3 there. And then what is there? The displacement at that time, it is 11 somewhere here, 11,25 somewhere here, and then we just plot 11,25. Those are our points, and then we just join the curve and then go. Okay, this is going to represent what? This is going to represent the ground. Okay, that is how we plot what to call the velocity time graph and the displacement time graph. Remember, for my displacement time graphs, I took the initial position of the object as my 0 reference. My name is KAMVA MVAKADE. Let's meet on the next lesson, where I will be drawing the same graphs, where we take the what you call the ground as the 0 reference. Thank you.